DD3DBiz.com, giving you an update right here in the research. So I'm going to go over some of our previous technology here that we made. This is an older battery made with a clear copper pipe, and it has the Epsom salt, Elmer's glue, basically the configuration seen in the previous videos. This has been dry now for about a week. There's been no water added or anything. And I've noticed after about, when it's completely dried out, by the way, it's a sodium silicate coating. After these are completely dried out, they'll always have a standard voltage of about 0.7. So I'll show you here, basically with the leads. Going to connect these up right here. It will always be around 0.7, 0.70. It's usually around that voltage. And it's very, very interesting. That's without any moisture added whatsoever. And this has been dry for about a week, sodium silicate, pure copper pipe cell, etc. Now, when I add the water here, watch what happens. That's it, just a little bit of water. And it's basically gone up right now. I don't know if you guys can see that, but it's about 1.44. And it'll stay there for quite a few hours at that voltage. By the way, I'm using distilled water. Distilled water, basically to reduce the amount of corrosion. Corrosion is the biggest factor right here with this stuff because the magnesium corrodes easy. But the sodium silicate has been a great protector. But even on the dry voltage without any moisture, this will stay always at about 0.70 volts, maintaining the Casimir or the 0-point energy voltage. This is the other one with the same configuration. I added water to it earlier, a few hours ago, and it had been dry also for about a week. Sodium silicate coating, as seen in the previous videos how it was made, and it has also maintained a voltage when I looked at it this morning of about 0.70. Once again, when I apply the electrodes, I added water earlier, a few hours ago. Still steady at 1.5 volts. So it's still doing pretty good. And even dry, it's still well over half a volt. This is dry. Now, as for the latest videos, these are the ones that were, the latest technology I've been working on. These are the small copper pipes that yield the same amount of voltage, but it's about half the size. Basically, this here is dry. It's been dry now for about 3 days, and it's become very flaky, very crusty. So what I did was I put sodium silicate on this one here. This is all sodium silicate coated, so all the flakiness and crustiness is gone. I didn't put any in here yet, maybe later on, but the sodium silicate really cuts back on the flakiness and makes it a nice firm coating. One very interesting thing also is once these have dried, the voltage is not as strong because there's no moisture. You've got to have moisture for the voltage. So as you'll see right here when I hook the leads up on this one right here, a nice piece of magnesium right here. As you can see, there's not a lot of voltage being applied right here when I'm putting the magnesium on the end of here. But because the sodium alginate, which was shown previously in the videos, underneath it here, there's a very, very fine layer of sodium alginate. And that sodium alginate is still very, very moist. It's like a gel. So what happens is, when we apply into here, let's just go underneath the layer here, even a small fraction, even a very, very small amount, like this, you'll see the voltage go up. That's about 0.28, 0.27. This is just slightly underneath the sodium silicate. And remember, this is dry. This is basically a gel underneath here, and that's what's creating the voltage, is the moisture in the gel. So what we do then is we make sure that we have a large area to cover the gel, and the more area that we can have cover the gel, the more the more stable the voltage. So what I've done is I applied magnesium ribbon going in through here like a sandwich, and it's going in through the copper pipe right here, but there's a layer right here, and the magnesium ribbon is going in between the layers right here, between these two layers. Because in the previous videos we had a layer of Epsom salt here, and then we had another layer here. So what happens is we have an increase in voltage, as I'll show you right here. I'm connecting the leads up right now, and I'll apply this one right here. We got a constant steady draw of 1.52 volts. I don't know if you guys can see that there, but that's a constant steady draw of 1.5 volts all the time. Now that's basically using this configuration right here. Once again, the stability of the voltage here is due to the sodium alginate gel, and sodium alginate is a very, very stable gel, and because it's a stable gel, it stays moist for a very, very long time. So I don't know if you guys can see here, but if you can look closely enough, you'll see right in here is where I've put the magnesium ribbon. So it's like a sandwich. Inside it's layered like this, and the magnesium ribbon is going through here. And so when we do that, we create a nice stable moisture pattern, or nice stable moisture area right here to give a lot of coverage for the current to flow. And basically that's how that part is done. In the next video, I'll give you some more information on how to increase the stability. You use very, very little water to keep these going and keep them as moist as possible. Once again, it's a very simple copper pipe. Thank you for watching. Stand by for the next video.